Good evening, ladies and gentlemen. Thank you very much for joining us for the SAIE 69th Bernard Price Memorial Lecture. Today, we are honored that our keynote speaker is the great-grandson of Dr. Bernard Price, Mr. Roger Price. Firstly, I just need to read you a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of the presentation will be made available on the SAIE YouTube channel, SAIE TV. The recording will also be made available on the SAIE website under the Events drop-down menu in the section Past Events and Webinars. This page is updated regularly, so ensure to check back as often as possible for new uploads and subscribe to our YouTube channel. A certificate of attendance will be issued a few weeks after this webinar, once we have received the CPD validation number from EXA. I've also, if you'll note, in the control panel at the bottom under handouts, there's the 69th Bernard Price Memorial booklet. Please, you can download the file and then, of course, keep it to yourself. I'd firstly like to introduce sorry, let me just show you, this is the agenda for this evening. We have a welcome by Professor Estelle Trengove, and then we have introduction of our president, Messiah Gourrah. Our keynote presentation is Roger Price. We have questions and answers, and then our vote of thanks is our Deputy President, Professor Sunil Maharaj, and then we close tonight. So let me introduce Estelle Trengove, who is the head of the School of Electrical Information Engineering at WITS University. She's a registered professional engineer and a fellow of the SAIEE. She worked as a newspaper reporter before studying to become an electrical engineer. She worked in industry at a firm of consulting electrical engineers for 7 years before joining WITS as a lecturer in 1999. She did her PhD on lightning myths and beliefs in Southern Africa. Professor Trengove.
Good evening. It's my pleasure to welcome you all on behalf of WITS University to the 69th Bernard Price Memorial Lecture. The lecture is hosted jointly by the SAIEE and WITS University to honor Bernard Price. The welcome is usually done by people much more august than myself. It's usually done by the Vice Chancellor. So I would just like to officially record the apologies of the Vice Chancellor, Professor Adam Habib, the Vice Chancellor Designate Professor Zeblon Vilakazi, and the Dean of the Faculty of Engineering and the Built Environment, Professor Ian Jandrell. The speaker is chosen for the SAIEE Memorial Lecture by the SAIEE President, and I'm very proud that this year the President is a woman, SAIEE Gourrah. Bernard Price is described as the father of electricity in South Africa. He came to South Africa as chief engineer of the Victoria Falls and Transvaal Power Company. Later, he became its general manager. This company is what we now know as Eskom. But Bernard Price was not just interested in electricity supply. His interests were wide-ranging, and that's why he's such an important person in the history of WITS. His interest in the sciences led him to establish the Bernard Price Institute for Palaeontological Research. Today, that institute has grown, and WITS is recognized internationally as a leader in the field of paleontology. In recent years, Professor Lee Berger of WITS's discovery of Australopithecus sediba in 2008 and Homo naledi in 2015 have contributed to our understanding of human evolution. Bernard Price is one of the people that made WITS the great institution that it is today, an institution that is ranked at number 266 in the prestigious Shanghai University rankings. It counts 4 Nobel laureates among its graduates, and it has graduated 180,000 students. As a proud Witsie, I welcome you to this virtual version of WITS University, and to the Bernard Price Memorial Lecture. I definitely miss exchanging personal greetings with so many of you whom I only see once a year at the Bernard Price Memorial Lecture, but I look forward very much to tonight's lecture, which will be given by a graduate from my school and the great-grandson of Bernard Price. Back to you, Minx.
Thank you, Professor. I now introduce you to our SAIEE President, Mrs. Gourrah. Gourrah has been part of the energy industry in South Africa for over 25 years. She started her career as a consultant and later was appointed as a city electrical engineer for East London. With more than 2 decades of experience as an electrical engineer, Gourrah also holds a number of qualifications, including a Bachelor of Engineering, Electrical and Electronics, Masters in Business Administration, and the Government Certificate of Competency. Mrs. Gourrah.
Thank you, Minx, and thank you, Prof. Trengove, for those warm welcome words on behalf of the university. Good evening, ladies and gentlemen, and honored guest, Roger Price. On behalf of the South African Institute of Electrical Engineers, I would like to welcome you once again to our prestigious Bernard Price Memorial Lecture. The first lecture was in 1951. This is the 69th lecture. And we are so honored and proud to have it being presented by none other than the son of the legend himself, Dr. Bernard Price. So just to give you a bit of a background in terms of Roger Bernard was born in South Africa and started working for Anglo Gold Ashanti as an engineer in training in 1999. He then completed his government certificate of competency and he joined DRA Mineral Projects in August of 2005 as an assistant electrical engineer. He completed his master's degree in engineering, specifically project management, through the University of Pretoria in 2009. He then registered as a professional engineer and emigrated to the UK at the end of 2015. He worked as an E&I plant engineer at Eggersut Paper Board in Workington, carrying out electrical and instrumentation maintenance. And in January 29, Roger joined Arup and began working on the electrical distribution network upgrade as part of the Infrastructure Strategic Alliance for Sellafield. And Sellafield is known to be one of the oldest nuclear commissioning sites in the world. Traditionally, we've taken this Bernard lecture basically to every single major city in South Africa. And although we're having this as a virtual webinar, we are able to take it to all 9 centers of the South African Institute of Electrical Engineers within South Africa, as well as many members that have joined us today. So it's a warm welcome again from ourselves. And without further ado, I'd like to hand over to Roger to do his presentation on leaving a legacy. And I think he's actually living in the particular legacy as well. Over to you, Roger.
Thank you, Sai. Good evening, everyone. It's an honor and a privilege to be speaking to you today as the great-grandson of Dr. Bernard Price. I hope you're all feeling well and staying sane and keeping safe in these trying times. This evening, I would like to tell you a story, intrigue you with some history, and challenge you to think outside the hamster wheel that we find ourselves on. It's not every day that we get to talk about where we've come from and reflect on what brought us here. I often find myself counting my blessings and wondering how much of who I am is determined by luck and the random opportunities I've been given, and how much of it relies on my vision for the future and the risks that I've been bold enough to take. Now, growing up in a family where expectations were fairly clear, in other words, you will be an engineer, I've been lucky that I always knew I wanted to be an engineer, and this has happened to line up with my family's expectations. Although it may seem a little predictable, it also gave me a sense of belonging and purpose, and helped me keep focused on what I needed to do to establish a solid foundation in my career. Now, that's not to say that I've achieved all my goals and aspirations, but I do believe it has given me the ability to see my life and some of the situations around me with some objectivity. I'm always saying to my wife, life is full of trade-offs, and there is only so much we can do with the limited resources at our disposal. I'm sure many of us have found this to be true in both our personal and professional lives, leaving us to wonder, does what I do really matter? So let's think a bit about leaving a legacy. Surely this is something each one of us aspires to, something all of us would like to achieve, both at home and at work. Life, however, is never so simple. Some of us might die never to be remembered. Others will be infamous. And finally, there will be some of us that will change the world by some small amount in a way that is positive and will thereby be remembered with love, respect, and admiration. Now, I'll just say, what is a legacy? A legacy is defined as anything handed down from the past, as from an ancestor or predecessor, or in other words, what we leave behind or pass on to the next generation. I'd like to talk a bit about my great-grandfather Bernard Price, after whom this lecture has been named, and who has been an underlying influence in the trajectory of not only the members of my family, but also in the direction that electrical engineering took in South Africa. Forgive me for repeating some of the background information that is handed out with these lectures, or before these lectures, but I think it is worth dwelling on some of this to give context to what it means to leave a legacy. Dr. Bernard Price was born in 1877 in the UK and studied at the Central Technical College in Kensington, where he became an associate of the City and Guilds Institute. Interestingly, this institute is still a highly regarded educational organisation in the UK today. He exhibited great promise as a student and was lucky enough to join a leading British electrical engineering consultancy called Merce and McLennan in 1901, and at the age of 23 as the chief electrical assistant. Due to their work with electric power stations and infrastructure, he developed a particular interest in the operating difficulties that they were having due to faults on generators, transformers, and cables. This resulted in him being involved with the development of various methods of protection, with the best known one being the Mertz-Price differential system of protection. For the younger generation, I think this should highlight the importance and opportunity that finding a good mentor can have on our ability to impact the world around us. Now, for those of you who are involved with electrical protection systems, this may be a little bit boring. At the time, the development of differential protection was at the cutting edge of power engineering and presented a large step forward in being able to isolate faults and maintain network stability. Looking at the diagram, you can see a very simple version of differential protection, where the current entering the protected zone is balanced against the current leaving, and this results in a zero sum of current flow through the relay operating coils, which would otherwise trip the circuit breakers. This principle of measuring the currents that come into a system and comparing it to the outgoing is a fundamental principle for electrical protection. However, and again, it is never so simple. From this starting point, you need to factor in various scenarios, such as resistance of the pilot wires and the position of the operating coil, the relative to the CTs, because these become significant factors when you're using differential protection on a long cable. Or you could be using the same principle to protect a transformer, where you need to account for changes in current flow due to the transformer step-down ratio, the tap changer position, or whether it is connected in star or delta on either the primary or secondary sides. Now, I don't expect anyone to try and figure out how all this works during the presentation, but I wanted to give you a sense of the incremental development that goes on with everything around us in engineering. The way that we can take a simple idea and extrapolate it into multiple uses. I will be touching on this again a little bit later on. The various configurations that have been used for differential protection of cables, transformers, and alternators have proven to be fast and effective means of protection for many years and continue to be used around the world. However, developments in electronic relays have made significant improvements to this concept, and we are now able to do the same thing over many kilometers using optic fiber pilot signals and a myriad of other clever techniques. The world of tomorrow now faces even more interesting problems. With the introduction of photovoltaic power plants and the widespread use of inverters, variable speed drives, and other harmonic-inducing electrical components. I remember harmonics being quite a tricky subject at university, and I think there are many opportunities for the brightest amongst us to solve some of the fundamental problems that these produce. In fact, I recently attended a webinar on ABB's low voltage active harmonic filters the other day, and it highlighted the size of the challenges we face and the need to start controlling harmonics at source. So getting back to Bernard Price, after spending his earlier years doing what would now be called product development, in 1909 and at the age of 32, he accepted the position of Chief Engineer and Power Supply Manager to the Victoria Falls and Transvaal Power Company, known as VFP. With his guidance and contribution, the VFP was able to establish an excellent power supply system, which grew into one of the first large power grids in the world, later to be nationalized into what we call Eskom today. As a youngster, I can remember my grandmother regularly telling me I should do a VFP job, referring to the quality of workmanship expected from those who worked for Bernard Price. This was probably because Bernard Price was a person who didn't accept poor quality. And I imagine he is one of those people you liked, respected, and probably feared at the same time. I'm sure many of us have worked for people like that, and you can't help but admire what they achieve. It makes me think of Elon Musk in some ways. Although I would never presume to compare their personalities, I do recognize a certain level of vision and single-minded focus that pioneering engineers display. Bernard Price became president of the SAIEE in 1915 and at the age of 38, and that was just after the start of World War I. In the context of having 4 children and serving as the chairman of the advisory committee on science and technology for the South African government at the time, it was evident that he was a respected leader and a hard worker. His work ethic and dedication to the success of the Victoria Falls Power Company led him to becoming the general manager in 1927 at the age of 50, and possibly not as an impressive achievement as our current SAIEE president, but still a respectable achievement. So you may be wondering, and possibly yawning at this point, about having to listen to a blow-by-blow account of some bygone engineer's career development. But I thought I would just put things into chronological order so as to illustrate the roadmap of Bernard Price's career was not too different to many of us. He was a promising engineer that focused on his work, behaved with integrity, and thought about more than just his own self-interest. This example was passed on to both his children, as well as those that worked with him. When comparing this to the achievements of engineers around the world today, the career of Bernard Price may seem better than most, but by no means particularly remarkable. So what makes him a great man and an example to generations of engineers that have followed? Well, in my mind, it is what he did after the age of 50 that set him apart from the rest. From a solid foundation in engineering, he went on to apply skills to more than just work. He took an interest in WITS University and became a member of its council and helped establish the Department of Electrical Engineering. His interest in lightning led to the establishment of the Bernard Price Institute of Geophysical Research in 1937, probably as a way of expanding our knowledge in this area and in order to solve some of the distribution network problems that they were having at the time. And in 1945, after a public lecture by paleontologist Dr. Robert Broom, where he highlighted the fact that thousands of fossils were being lost due to a lack of proper facilities, Bernard Price decided to establish the Bernard Price Institute for Paleontological Research at WITS University, so that the fossils of South Africa could be collected and preserved. When we look at what makes the difference between good and great people, it is not the money that we make or the accolades that we achieve that sets us apart. Rather, it is our attitude to people and the world around us that counts the most. To quote an excerpt from a letter written by his son, Michael, after his father's death, it goes, "I cannot help feeling all the time that it is not only a father whom we have lost, but a very great man, whose wisdom, encouragement, and leadership is lost to his country equally as to his family. No one could have wished for a more understanding, generous, and wise father, or one who set such a fine example in his life for his children to try and follow." Now, in my family, Bernard Price has left a legacy through the standards, integrity, and behaviors that he passed on to his children, and which I recognized in my grandfather. And in the world around us, he is remembered for his vision in contributing to the greater good and the example he set for the future generations. So what is the takeaway from this little story about Bernard Price? What is relevant to us today, both at home and in the workplace? Well, for me, it is that it's the quality of what we do and the attitude with which we do it that resonates the most. Right, so thinking a bit about quality in the workplace, I would like to chat about CDM and what that means for me. I'm currently working in the nuclear industry, which would be classified as highly regulated environment. But one of the things I've noticed is that even though there are hundreds of procedures and processes in place, mistakes do still happen. It invariably comes back to human error and the quality of the work being performed, be that the correct following of procedures, or what we could call quality of behavior, the quality of the designs, or the quality of the workmanship. In the projects I'm currently involved with, construction regulations that encompass both design and management aspects are being actively used to guide the creation of the processes that we use to carry out our projects. This is commonly referred to as the CDM regulations. Now, I won't bore you with the legal jargon around CDM. However, the principles of eliminating, reducing, or controlling risk throughout the design process and passing the residual risks over to the construction team in a demonstrable way is a core part of the CDM requirements. This has a direct impact on the approach used by designers in carrying out the design work and results in a highly integrated environment where the focus is on communication, collaboration, and control. In the projects that I work on, there are clear responsibilities allocated by the regulations for the client, the designers, and the construction team. And although we work together to make sure that every question is answered and that the design meets the requirements, it is all carried out within a framework that encourages everyone to get involved and take responsibility for the end product. We have meetings between the client, the design team, and the construction team on a regular basis, and any issues are addressed immediately under the guidance of the principal designer and the principal contractor duty holders. Now, for those of you who have worked with or implemented CDM principles in your project, you will recognize that the underlying aim of the regulations is to ensure improved health and safety by legislating responsibilities in order to increase the quality of the design and the construction processes. However, as with everything in life, it is our attitude that makes the difference. No matter what the system, if people don't support it wholeheartedly, then it is doomed to failure. Right, enough of the heavy stuff. Let's relax and listen to the poetry of Wordsworth, Coleridge and Southey. For those of you who know their poetry, that is, and spend some time drinking in the beauty of the Lake District, where these literary artists grew up. Let's close our eyes, listen to the birds and float along the river towards the energy coast and the whoop, whoop, whoop of wind turbines, the glassy reflection of solar panels and the metropolis of the nuclear facility called Sellafield, situated in the northwest England in a remote coastal location with the Irish Sea on one side and the mountains of the Lake District on the other. So this is the Sellafield nuclear decommissioning site. Having looked at a personal legacy, I thought it would be good to cover some of the history about where I work. A company or global legacy that is close to the heart for many of us, namely nuclear legacy. Sellafield is located in a lovely part of the world that is quite rural in many ways. But the thing that strikes me most about the area, and probably in Europe in general, is the fact that you are surrounded by history wherever you look. And this can be anything from Hadrian's Wall to a Roman ruin in your backyard. So the first question is, why place a nuclear facility right next to an area of outstanding natural beauty? Surely we don't love the nuclear scientists that much. Well, the story begins with the requirement for a TNT production plant at the beginning of World War II. The Sellafield site was chosen because of its remote location and the fact that it was too far west for German bombers to reach. As Britain celebrated the end of the war, new tensions between East and West led to what most of us will remember as the Cold War. Atomic weapons were seen as the best deterrent to a third world war, and although Britain had been working with the American scientists at the time, the Americans stopped this collaboration, leaving Britain with the need to start up its own atomic program. Since Sellafield was already a bomb-producing facility, it was almost logical to repurpose it for the nuclear research and plutonium production, resulting in a nuclear legacy that makes up some of the most hazardous work that needs to be carried out on the site today. At that time, the site was then renamed Windscale, and the work started in 1947 with the single mission of producing plutonium for use in Britain's nuclear deterrent. The Windscale reactors that were producing the plutonium were found to be generating a significant amount of heat. In 1952, this led to the building of 4 new nuclear reactors on the site, specifically for the production of heat, which would be used to produce electricity in the world's first commercially sized nuclear power station called Calder Hall. I'll now put on a short video showing you a bit of the construction of Calder Hall.
In August 1953, the foundations were dug for a great concrete raft to carry the 8-sided. In August 1953, the foundations were dug for a great concrete raft to carry the 8-sided biological shield, with walls 7 feet thick, lined with 1,500 tons of 6-inch steel plate. To support the 2,000-ton weight of the pressure vessel, there were 10 steel legs, each weighing 5 tons. A crane 200 feet high lifted into position the sections of the pressure vessel. This middle section weighed 90 tons and cleared the top of the concrete by less than 2 feet. The grid to support the graphite core of the reactor was 36 feet in diameter and weighed 63 tons. The lifting of the upper ring and top dome completed the pressure vessel. Raising the heat exchangers was another heavy lifting job. Each was 80 feet high, 17 feet in diameter, and weighed 200 tons. Into the heat.
Right. Like the saying goes, what goes up must come down, and everything that gets exposed to nuclear radiation must be stored or responsibly disposed of. Now, I say that because the great legacy of creating the world's first nuclear power station also leaves us with the challenge of breaking it all down again and disposing of this waste when we are finished using it. When I think about legacy and the difficulties we are facing trying to dispose of the nuclear errors of the past, I'm led to thinking about the cutting-edge technologies we are developing today. I'll be interested to see what the world does when the photovoltaic cells on roofs and the lithium-ion batteries in the houses of today begin to fail in 20 years' time, and we are called on to dispose of or recycle this waste. Hopefully we have learned the lesson, and the next generation is even better at recycling than what we are. Right, back to the history. In October 1957, a fire broke out in the Windscale reactor number 1. And as the Windscale reactors were designed specifically for production of plutonium, they contained a significant amount of radioactive material. The filters at the top of the Windscale pile chimney were the only thing that stopped this disaster from becoming a catastrophe, as it limited the amount of radiation released into the environment. The Windscale fire was a wake-up call for the nuclear industry at the time and led to vast operational and technical improvements in nuclear reactor design, the technology, licensing, and regulation. I'll just show a short video on the Windscale reactors now.
So the pile chimneys were constructed in approximately 1947 in support of the UK's weapons programme. At that time, John Cockcroft, or Professor Cockcroft, went across to the USA and observed some activities across there and identified the filters adjacent to the reactors that were there. And he insisted when he came back to the UK that we put filters on the pile chimneys. Because the pile chimneys were constructed at that time, those filters had to be mounted over 100 metres up in the air. Post the fire in 1957, both reactors were shut down. That's pile 1 and pile 2.
The pile chimney 1 experienced the fire in 1957 and as a result was quite heavily contaminated with radiological material. It's only now and after a prolonged period of time that that radiation and contamination has naturally decayed to an extent that it's safe for us to operate and access the chimney and in its surrounding areas. Our most significant challenges for demolition of the pile 1 chimney is basically where it exists in a very congested nuclear site. We've got to deal with an awful lot of infrastructure that exists around the chimney. Access and egress can be restricted. We are operating at 110, 120 metres above ground level, so we've got weather constraints and issues to consider, conventional safety hazards, and we're talking about 5,000 odd tonnes of material that we're going to eventually have to dispose of, and all those elements in themselves are quite significant challenges for us.
Right, Well, from that video, you can tell that there is a lot of work to do. To remove this part of the Sellafield site, and looking at the amount of work required to decommission Sellafield as a whole, it is forecast that it will take about 100 years. So I can just imagine the effort that the Japanese are going to have to put into rehabilitating the Fukushima Daiichi site after the major disaster that occurred there. A few years after the Windscale disaster, should I say, research into nuclear fuel reprocessing was started at Sellafield, which resulted in the development of a new facility in the 1980s and 1990s called THORP, or Thermal Oxide Reprocessing Plant. This plant was used to recycle more than 9,331 tons of uranium for customers around the world, and meant that 97% of the used fuel could be recycled. Unfortunately, this process became financially unviable because it is now cheaper to mine uranium than it is to reprocess it, and so potential customers have opted to store their spent nuclear fuel. Thorpe ceased its reprocessing operations in 2018 and is now used as a storage facility for used fuel. This being said, it is important to note that in an operating nuclear plant, only 1% of the waste generated is highly radioactive. And in the vitrification process, where this high-level waste is dried out and integrated into a glass product, it is reduced in volume to the point where it is relatively insignificant. It is then encapsulated in a stainless steel container and placed into specially engineered storage facilities. In contrast, we release billions of tons of carbon dioxide pollution into the air each year, which is produced by coal-fired power stations worldwide. The last bit of interesting legacy I want to touch on is the Magnox Swarf storage silos, where tons of nuclear waste have been put away for storage in a less than optimal configuration. I will now put on a short video to take you through a bit about this challenge, the challenge that is facing this facility.
It's our number one hazard, so safely decommissioning it is our number one priority. The Magnox Swarf storage silo, the biggest challenge in our big four legacy ponds and silos.
So this is the Magnox Swarf storage silo. It comprises of 22 concrete silos. It's been built since the early 1960s and extended 3 times in total. Each of them is the size of about 6 double-decker buses. They're water-filled, and the waste is predominantly the products of Magnox reprocessing. So it's a corroded Magnox alloy that over time has degraded into a sludge. The corrosion of the swarf creates hydrogen gas, which we're all aware of is highly flammable. So we're constantly having to ventilate each of the compartments to make sure we don't get an unnecessary buildup of hydrogen. The reaction that's taking place is also exothermic, so it's naturally wanting to heat. And as it heats, the creation of hydrogen starts to accelerate. So it's really quite important that we maintain temperatures in here. So we're constantly cooling the silo liquors as well. It's a very hazardous environment. There is nothing comparable, certainly that we're aware of, anywhere in Europe or possibly the world.
Emptying the facility is expected to take more than 2 decades. Due to the complexity of the task, it's taken a similar amount of time to plan and prepare for the job.
This facility was never designed to be emptied. I'm not quite sure what the thinking was about what would happen to this material in the fullness of time. But that legacy has been handed on to us. We have to deal with it and have to take that responsibility. So it's important that we get this material out, certainly in our generation, and make sure we leave things safe for those coming along after. For the benefit of the long-term hazard reduction that we know we've got to achieve, we may have to accept some short-term increases in risk along the way.
This is the first of the 3 mighty machines which will be grabbing the waste and lifting it out. The silo emptying plant, weighing nearly 400 tons and lifted into the building in 22 different modules before being reassembled inside. Some waste was taken out of the newest part of the building in the 1990s with a different machine to prove the retrieval's concept. But these shielded caves on rails are what's needed for the big job ahead.
So the process for retrieving waste, which we have trialled back in the 90s, successfully demonstrated, it's quite simple really. The machine itself locks itself over a silo and seals itself around a hole. The basis of the machine is a hydraulic grab on a hoist drum. So we lower it into the silo, close the grab, and grab and pick up whatever waste it happens to find there. So we're not selecting specific elements of waste. It's more like a fairground grab, a lucky dip arrangement, if you like. When the grab is retracted into an operator bulge where we can see what we've got, the waste is tipped or dropped into a stainless steel skip, which is effectively a meter cubed biscuit tin. And we continue to repeat that cycle until we've got sufficient waste to fill the skip. The skip is then withdrawn along a tunnel that's part of the machine and lifted into a bottom opening flask, which is sitting on top of the machine, which shields the waste, but also acts as a transport container to move it to another facility elsewhere on site.
Right, thank you. The Sellafield site has over 70 years of history and today presents one of the most significant environmental remediation challenges in Europe. However, this seemingly negative legacy has delivered huge benefits for the UK and the world of nuclear power as a whole. If we look at the progress made so far in the decommissioning process, there has been quite an impressive change to the impact on the skyline. As you can see there, just to give you some perspective of the progress made so far in the decommissioning process, you can see at one stage there were a number of tall structures on the Sellafield site. And if we carry on, there's now been quite an impressive change to the impact on the skyline, with most of these structures removed, and the windscale chimney that you can see there now is steadily getting smaller. And in the last 2 years, I've noticed it drop quite significantly. All right. So why cover these bits of history and comment on the challenges that Sellafield is facing? Well, firstly, working there, I'm faced with the problems associated with legacy issues every day. And secondly, it gives us an appreciation of the complexity that we are left with if we don't start with the end in mind. One of the challenges that the Sellafield site has is the maintenance or replacement of aging infrastructure that is required to keep things going while the ongoing decommissioning processes carry on. On the face of it, this may seem like any other brownfields job that you might get involved with, except that given the age of the site, you cannot do anything without thoroughly investigating the impact of your actions. For example, you cannot dig a trench or bury a cable without first investigating old records to see what is underground in that area. You then need to carry out a GPR or ground penetrating radar scan to confirm the old records are correct. And then for good measure, you will need to excavate a trench or slit trench using safe digging techniques like a vacuum excavator or plastic spades in order to confirm that the old records and the GPR scan are in fact correct and that you will not impact existing services. Furthermore, as though hitting buried services is not enough of a problem, there's also the requirement to test for asbestos and radioactive materials in the ground that is being removed. Although there are surveys that highlight where the main areas of concern are, this does not remove the requirement for sampling and testing as the digging operations are carried out in order to double check the existing records. This may seem a bit over the top, but like any rule or instruction, it is based on incidents that have either led to an accident or have nearly done so in the past. So just to reiterate, we need to start with the end in mind. As an aside and a bit of an observation, nuclear was the most popular technology 70 years ago, and everyone thought it was the holy grail of power generation. However, when we look back now, we can see that a little caution and forward planning may have made the legacy that was left behind a bit easier to deal with. In the same way, we are entering a new era, where wind farms, photovoltaics, and batteries are fashionable and becoming hugely pervasive. We think that we will continue to develop and improve these technologies for years to come, possibly recycling and maintaining them into a green and beautiful future. However, consideration of technologies like fusion power, superconducting cables, and deep sea energy storage systems, and a myriad of other variances on the theme, may challenge the current trends and offer a lower cost per kilowatt hour in the future. The speed with which the various technologies are evolving is mind-boggling, and it may be that the world needs to consider the balance and efficiency of each technology very carefully before committing to any one solution. We don't want to end up in the position where our great-grandchildren are looking at us and asking, why did you fill the countryside with toxic solar panels and redundant wind turbines? Didn't you realize that it would take years to collect, dismantle, and recycle all the waste that was produced? I'm not saying that renewables are a bad technology or that it isn't a necessary step in the evolution of man towards a brighter future, but rather I hope to illustrate that it is important that we learn from the past and plan for the eventuality that everything we create today will need to be disposed of. As engineers, we are the artists of science. We take the raw materials around us and create new and incredible things. It is up to us to behave in a responsible manner that ensures the health of our families, the safety of our colleagues, and the sustainability of the world in which we live. I work for ARIP, a company where our mission statement is, we shape a better world. And this resonates with my belief that we should continually strive to make the world a better place for all. We are surrounded by visions of a world that is enhanced through digital technology, clean power, and a symbiotic relationship with nature. And I hope that we are all striving for a sustainable future where poverty and pollution are a thing of the past. There is more opportunity now than ever before to make this vision a reality. And all we need to do is stand tall, behave with integrity, and focus on quality in everything that we do in order to leave a great legacy for our great-grandchildren. So, some of the things that you can do to leave a legacy would be create, be that through singing, writing, building, or designing. Be a role model and behave the way you expect others to behave. Learn to give and be generous with your time and possessions. And finally, inspire by sharing your wisdom and knowledge with those around you. When I look at the life that my great-grandfather lived, I believe he did all of these, and is therefore remembered as the great person that he was. So I thank you for listening, and please feel free to ask some questions. Thanks.
Thank you very much, Roger, for that really excellent presentation. If there are any questions, please use the question box that we have so that I can start giving Roger the questions. So I've got the first question from George Debo. He says, how has COVID-19 affected the decommissioning operation at Sellafield?
That's actually quite an interesting question. To start with, there was obviously everybody stopped working. I wouldn't say stopped working. There was a structured ramp down of work on site. Whatever didn't need to carry on working was ramped down in a structured way. And it went into a sort of a low hum for a while. And then I think probably in the last 2 months, things have started picking up again, especially on where in the area that I work in, which is projects. We've started to start the construction side of work again. From a designer's point of view, which is the area that I work in, we were actually affected quite significantly with COVID because we had to sort of ramp up the design operations to keep things rolling, keep things going. So the focus moved from construction and design as a balance to just design work. and all the construction teams were ramped down and the designers were ramped up. So I've had a very, very busy last 6 months. Yeah, I hope that answers that question.
Thank you very much. I've got a comment from Pat Naidu. He says, first class lecture, thank you very much. And then there is also a comment from Mohammed. He says, thank you for an insightful lecture. Definitely some very important points to reflect on. And then there's a question here from Jeff. He says, how many sites like Sellafield are there in the UK, in the world? Is there a staffing problem worldwide?
I don't know how many sites there are like Sellafield, to be honest. I know that Sellafield is one of the earliest ones in the world, and especially since they started with the power station side of things. So yeah, I don't know how many of them have the same sort of history, but I think in the early days they weren't very careful or fastidious about how they put things, you know, stored things, or what they did with nuclear waste. So there were quite a lot of challenges that they've created, like with that MSSS or magnetic storage silo. I don't know if you can say that fast, but that whole facility is quite it's, you know, they said they started in the 1990s to try and work out how they were going to empty these silos, and it's only 20 years or 25 years later that we're really getting into the motion of getting them emptied. I know that from what I can remember, I spoke to somebody the other day who said that there were 3 of those what they called tunnels on wheels, or whatever it was, caves on wheels. There were 3 of those planned, and I think the 3rd one was installed within the last year. So they've now finished installing all the equipment, and they're continuously trying to empty out what they can. But I'm not involved in that sector of the site, so I can't give much more than that, I'm afraid.
Okay, and then there's just a comment from Andrew Lewis. I don't know if he knows you. He says, wish I'd known you come from such a pedigreed background while at university. I might have done better and paid more attention. Then there's a question from...
I was going to say, thanks, Andrew. It's been a while. We must catch up again sometime. Yeah.
And then there's a question from Ricardo. It says, considering how wind turbines prevent the wind energy from moving through the land and enriching it, what is your take on this technology?
I think wind turbines is a very double-edged sword. You saw some of those photos that I put up. It's not because I don't think wind turbines or using the wind for energy is a bad idea. I think it's an excellent idea. But it has got a major impact on the landscape. We live in an area which is called the energy coast of the UK, and that's not for want of a bad or any other reason other than they've got wind turbines, we've got solar panels, we've got the nuclear facility, and we're in the middle of a really, really beautiful part of the world. So it's a contrast which is hard to reconcile, I think, in your own head. Do you like it or don't you like it? From a visual perspective, I don't like them at all. From a renewables point of view, I can totally see the value add. So yeah, that's why I say you might not want to jump in with both feet. I think there's the message there is really to weigh up what are the other technologies that are coming. There's some really good stuff on the horizon, and some really interesting stuff. And you know, I just think if it's like nuclear, if you jump in flat out, you might end up with a legacy which you need to now remove, you know, 50 years down the line. So that was the best answer I can give on that, I'm afraid.
Okay, so I'm going to ask 2 more questions before we start wrapping up. So the next one is from Bruce, and what he's saying is, should new nuclear plants be designed to burn up some of the old nuclear waste?
Should new nuclear plants be designed to burn up old nuclear waste?
Correct.
I'm not a nuclear physicist, I'm afraid. I could not tell you that. I think new nuclear plants, or the new generation of nuclear plants that are coming out now, and I'm not on one of them, so unfortunately I can't really comment very well, but I think they have got a lot of technologies in line now that are really challenging some of the benefits that you might have seen, you know, some of the balance against, say, renewables. So it's a continuous progression of technology, and I think we've got to sort of absorb some of them and try and find the right balance between, you know, the different technologies and the different places we put them. If you put nuclear near a city which is using a lot of power, that might make some sense. If you in a rural area and you put some solar panels down, that also might make some sense. And if you can find a good way of storing electricity generally, then wind and solar and all that sort of stuff might come into their own. So yeah, it's a big debate, and I think it's an interesting one. But I can't say whether new nuclear plants will burn up old fuel. I don't know. I don't think it quite works like that.
Okay, and then you've just got a comment from Roger saying that he really likes your slide about the legacy. And then there's a question here from Trengove. He says, Roger, what do you think about the lifetime of nuclear energy?
I think nuclear, in my mind, it's here to stay. Maybe not as fission nuclear, but as fusion in 50 years' time or whatever it is. There's been a lot of good developments, and fission as well. I mean, there might be a way of making it less harmful. High-level nuclear waste is not a nice thing to have, but at the same time, it is very small quantities relative to what power output you're getting. So you've always got to weigh it up against the impact on the environment and whether you can manage that waste. Our history with nuclear is really bad. As you can see, there's some terrible examples out there, but at the same time, you know, if we do it properly and we do it responsibly, then it's not all bad. So yeah, I feel that nuclear is around to stay, but probably on a fusion level rather than on a fission. Yeah.
I'm going to take one last one, and it's, what's your take on hydrogen, or more precisely hydrogen fuel cells, as an alternative energy storage compared to batteries and an alternative means to generate electricity? And it's from Zwandile.
I think hydrogen's actually got a lot of benefits. I'm not an energy expert, so I'm not going to pretend to say, well, I know that it is better than batteries, but I think batteries are quite toxic, and the problem they have is that they're distributing them throughout the country, throughout everybody's household. They're everywhere, and they're very pervasive. And I think using it as an energy storage system on a grid level sort of take might be a bit foolhardy, or a bit jumping the gun, because there are other ways to do it. You know, be that pump storage systems, or as I say, this undersea. It's worth looking up undersea energy storage systems. And hydrogen probably is one of those as well, to be honest. Versus batteries for cars, maybe when it comes to cars and that sort of stuff, batteries might come into their own. So that's my take on it. But you know, it's an evolving space. Things change regularly and rapidly. So maybe I'm talking rubbish, and you'll find a better answer next year.
So before I hand over back to Minx, thanks a lot again for that lecture. But I have to say, there's a comment especially here from Richard Price. So he says, great lecture from Rich, Jill and Jenny in South Africa. So I think we found another prize to do the next one. So Sunil, please take note. Thank you
Thanks
again from my side.
All right, thanks very much, guys.
Wonderful. Thank you very much, Roger and Sai. I appreciate that. Now, our vote of thanks is tonight by the SAIEE Deputy President, Professor Sunil Maharaj. Professor Maharaj became an SAIEE member in 1996. He completed his Bachelor of Science in Engineering, Electronic, and Masters of Science Engineering at the University of Natal. In 2005, he was instrumental in establishing the Centec Chair in Broadband Wireless Multimedia Communications at the University of Pretoria. He has supervised and mentored many students from honours, masters, doctors in philosophy to postdoctorate level. Professor Maharaj, I hand over to you.
Thank you, Minx, and good evening again to our SAIEE members, and of course our hosts this evening, Prof. Estelle Trengove, and our president, Gourrah. My job is pretty simple, to do the vote of thanks. First of all, I'd like to thank all our attendees. And the last count I had was in the region of 160 that attended, which is quite good. and we thank you for that. And of course, I'd like to thank our speaker, Roger Price, for a very well-structured presentation. And what I enjoy the most is that I think there's history, and how you brought the history into legacy, and how you brought the legacy into applying into what we are doing today, and how we would leave a legacy for the future, and how we need to be conscious of what we do. And Roger, I think one of the things that for me stuck out was when you said that coming from a family or a great-grandfather of engineer, and you said that always the silent talk was that you will be an engineer, and of course as you liked it. But I think now for me the talk should be amongst all of us, whether you're an engineer or an artist or a musician, is how you will be an environmentalist, because I think we all collectively are busy destroying the planet in some way or the other, and that's not a good legacy for us to leave. And we all need to, in whatever we do, be very conscious of trying to be thinking about sustainability. And that's why the SDGs, the 17 SDGs, are so important, and we need to consciously and subconsciously think about it and talk about it all the time. And certainly I think you brought out a very important aspect in your presentation on how we need to think of everything we do, that maybe the flavor of the month at this point in time, but we need to think the impact it will have down the line, maybe 20, 30, as you mentioned, 50 years in time. And thank you for that. And I think that's very, very relevant and pertinent in this day and age. I also like to thank our president, President SAIEE Gourrah, for thinking about you as one of the speakers, and it was certainly worth the while, and certainly bringing back history and a lot of remembrance and stature to this particular event we have been hosting for the last 69 years in partnership with WITS. And we'd like to thank our partner WITS University for working with the SAIEE on this particular event over the years in a very, very constructive and a very, very rewarding fashion. I'd like to thank also the CEO and the COO, and of course Minx from SAIEE for all the logistics, the planning, the invites, and so forth. Thank you very much to the team. It was wonderfully done, and everything is working very, very well. Even the technology today seems to be working very well, and we thank you for that. And Roger, I hope you, after the lockdown, sometime you'll come to South Africa and maybe still visit the SAIEE, and maybe we can still do another presentation in some other form, talking about other things that will be of benefit to our members, and of course benefit to society at large. And I'd like to thank everybody for attending. Wonderful having you here. Certainly our members of SAIEE, I'd like to thank you very much for your continued support, and hope you continue your support and membership to the Institute, and hopefully collectively we can add value to our members and grow the Institute and make a positive contribution to society, both in South Africa and at large. And thank you very much, President, and I'll hand it back to you, and have a good evening, and stay healthy and stay safe.
Thank you so much. And in closing, I just want to take this opportunity once again to thank Roger for accepting our invitation and taking the time out of your very busy schedule. I know how hectic it was, and especially to honor your great-grandfather, his legacy, and this annual lecture. So from our side, South African Institute of Electrical Engineers, and on behalf of myself, I'd like to just thank you once again, and it was indeed an honor and pleasure to host you. But I definitely look forward to future collaborations with yourself, and definitely with WITS University as well. I'd like to just take this opportunity to thank you all. And thanks to all the participants as well for attending this webinar. And I think we did have quite a record attendance as well. So thanks a lot, Roger, and keep safe and enjoy your evening further.
Great. Thank you very much, Si. Really appreciate it.
Cool.
Keep well.
Thank you.